We're going to continue our factoring review. So first, we're going to look at difference of squares. A difference of squares, we have a binomial in the form a squared minus b squared, and it would factor to two terms, the square root of a squared, which is a, the square root of b squared, which is b, and one would get a plus, one would get a minus. So it factors to a plus b times a minus b. So for example, if we have 4x squared minus 9, we would always first check to see if there's a greatest common factor. We do not have one here, but the first term is a perfect square. 2x squared gives us 4x squared. That makes a equal to 2x. 9 is a perfect square. 3 squared is 9. That makes b 3. So when we factor it, the square root of 4x squared is 2x. The square root of 9 is 3. One set of parentheses gets a plus. The other one gets a minus. So 4x squared minus 9 factors to 2x plus 3 times 2x minus 3. Okay, let's look at perfect square trinomials. So there's two forms for these. One is a squared plus 2ab plus b squared equals a plus b quantity squared. The other is a squared minus 2ab plus b squared equals a minus b quantity squared. So for example, 9x squared plus 24x plus 16. We would still always look to see if there's a greatest common factor first. Here there is not, but the first term and the last term are both perfect squares. So we will see if we can use one of the formulas for a perfect square trinomial. The middle term has a plus symbol, so we're looking at this first formula. So we're going to put down parentheses squared. If we look at 9x squared, the square root of that is 3x. The last term is 16. The square root of that is 4. Because we're looking at that first formula because of the plus. That formula has a plus, so we put a plus. So it potentially factors to 3x plus 4 in parentheses squared. But we do need to check that middle term that I've underlined, the 2ab. So we need to see if 2ab equals this 24x, meaning does 2 times 3x times 4, does that equal 24x? Well, 2 times 3x is 6x times 4 is 24x. So yes, 24x equals 24x. That checks out. So yes, this factors to 3x plus 4 in parentheses squared. Let's look at one more. 8x squared minus 24x plus 18. Well, if we look at our three terms, we have a greatest common factor here. That is 2, so let's factor a 2 out of everything. We end up with 4x squared minus 12x plus 9. Now, if we're looking at what's in parentheses, 4x squared is a perfect square, 9 is a perfect square. We're going to see if we can use one of our perfect square trinomial formulas. So I'll set that up. We still have that 2 that we factored out in front. The square root of 4x squared is 2x. The square root of 9 is 3. We have a minus here in front of the middle term, so that means we're using that second formula, so I'll put a minus in our parentheses. So this is potentially factored, but again, we need to check that middle term. So does 2 times, and I see I left off the x, let me fill that in, does 2 times 2x times negative 3 equal negative 12x? Yes, 2 times 2x is 4x times negative 3 is negative 12x. So negative 12x does equal negative 12x. That does work. That checks out. So 2 times the quantity 2x minus 3 in parentheses squared is how this example factors. Okay, let's look at sum and difference of cubes. Now, unlike a difference of squares, we have both a sum and difference of cubes. The sum of cubes formula is a cubed plus b cubed equals a plus b times the quantity a squared minus ab plus b squared. The difference of cube formula is a cubed minus b cubed equals a minus b times a squared plus ab plus b squared. Let's look at an example. If we have a cubed plus 8, okay, there's no greatest common factor. X cubed is a perfect cube. What cubed is x cubed? X. So a is x. Then, what cubed is 8? 2. So b in the formula is 2. So then, we're using that first formula because we have our plus, we have a sum of cubes. So I'm going to write the right-hand side. So it factors to a plus b times a squared minus ab plus b squared. Let's substitute in our a and b. So we have x plus 2 times x squared minus x times 2 plus 2 quantity squared. Let's simplify. So I have x plus 2 times x squared minus 2x plus 4. Now, with the sum and difference of cubes formula, even though we have something with an exponent in that second parentheses, if we had already checked and there was no greatest common factor, we will not be able to factor further that quadratic trinomial. So this is completely factored. Let's look at one more example of this. So 8x cubed minus 27. Again, there's no greatest common factor, but I do have a perfect cube here. What cubed is 8x cubed? 2x. So a is 2x. A minus. What cubed is 27? 3. So b is 3. Now I'm using the difference formula, which is the second one. So let's write down the right-hand side, a minus b times a squared plus ab plus b squared. Let's substitute in our a and b. So I have 2x minus 3 times 2x in parentheses squared plus 2x times 3 plus 3 quantity squared. Let's simplify. So I have 2x minus 3. And then I have 4x squared plus 6x plus 9. Again, remember that quadratic trinomial from the difference in sum of cubes formula does not factor further. So this is completely factored. Let's look at one final method of factoring. Let's look at factoring by grouping. And we've already looked at this a little bit. So here's an example of factoring by grouping. X to the fourth minus 2x cubed plus 8x minus 16. I will use factoring by grouping when I have 4 terms. So when I have 4 terms, I'm going to split this polynomial in half. So I'm literally just going to put a little squiggle splitting it in half, so I have 2 pairs. And then I'm going to factor a greatest common factor out of each pair. So if I look at x to the fourth and minus 2x cubed, my greatest common factor is x cubed. And when I factor that out, I'm left with x minus 2. And then if I look at the second pair, I have 8x and negative 16. My greatest common factor is 8. My third term is positive, so it's positive 8 that I'm factoring out. If my third term were negative, I would factor out the negative. When I factor out that positive 8, 8x divided by 8 is x. Negative 16 divided by 8 is negative 2. So you'll notice I have a common binomial term here. We should get a common binomial term here. If we don't, we did something wrong. Now we're going to factor out the common binomial term. Or if we don't get a common binomial term, then we can't use factoring by grouping, I should say. But so we did get a common binomial term. We're going to factor that out. So I'm going to factor out that x minus 2. And now I'm left with the x cubed plus 8, which goes in that second parentheses. Now, I could be done, but any nonlinear factor, we should factor again if possible. That means any factor that has an exponent inside of it, we should check to see if we could factor it again. So here we've got a sum of cubes, and we've actually already factored that, but we'll factor it again really quickly. So that first term is linear, has an exponent of 1 that's not visible. We can't factor it anymore. But here, what cubed is x cubed? X. What cubed is 8? 2. So x is my a, 2 is my b. It factors to x plus 2 times x squared minus 2x plus 4. And remember from the sum of cubes formula, that x squared minus 2x plus 4 cannot be factored anymore. So now we're done. Okay, let us just quickly summarize all of the methods that we've looked at for factoring. First, you're always going to look to see if you can factor out a greatest common factor first. Then, if you have a binomial, check to see if it's a difference of squares, or check if it's a sum or difference of cubes. If you have a trinomial, check if it's a perfect square trinomial. If it's not, then if a equals 1, use the x method. If a is greater than 1, use the x method and then factoring by grouping. And if you have 4 terms, then try to use factoring by grouping.